All right, you guys, April 29th, section 10.2. This is a two-section day, so try to get through what we can here in a reasonable amount of time. So we measured angles and identified congruent angles. We've done that many, many times before. Now we're going to look at some central angles, major arcs, certain parts of a circle. And so you're going to have some terminology here. We'll identify it and define it more clearly as we get going on. A central angle simply is an angle whose vertex is at the center of a circle, okay? An arc is a portion of the circle that goes around the outside. It's like part of a circumference. Minor arc means it's less than 180 degrees. Major arc is more than 180 degrees. We use 2 letters to define minor, 3 to define major, okay? A semicircle is 180 degrees, halfway around the circle, okay? Congruent arcs are arcs that have the same central angle in congruent circles, and we'll see that later, okay? Adjacent arcs are ones that are right next to each other. Arc length is the linear length. So you heard me refer to these as less than 180 degrees. We can talk about an arc in degrees. Arc length would be if I took a string and stretched it around the edge. How long would that be? So a fraction of the circumference. So all of the central angles in a circle have to add up to 360 degrees. That's one of the first things we're going to talk about. So in here, find the value of x. Okay, right here, r to v is a diameter, which means this is a semicircle from r to s to v. And so all of these central angles have to add up to 180. So I'm going to just add those expressions together and set them equal to 180, okay? And so simplifying a little bit, 8 and 13 is 21 and 5 is 26x minus 2. The rest is pretty straightforward algebra. Add 2, divide by 26. So x is 7. If I need to find any of the angle measures, I can put the 7 back into those expressions, but they just asked me for x here, so I'm good to go. All right, so really similar. Give this a shot. Let's see what we get. So again, here's a diameter. So all 3 of these are going to have to add up to 180. Okay, so I have 7x plus 5x. That's 12x. 2 minus 5 is negative 3 plus 75 is 72. Okay, a little bit of algebra. Subtract 72. Okay, and then divide by 12, and I get, what, 9? Okay, so I think we've seen problems like this before. I don't think this is going to be too big a deal for you guys. Okay, again, a minor arc. The shortest arc connecting 2 endpoints in a circle must be less than 180 degrees. So I would call that arc AB. Okay, so AB with a little arc of a circle above it. A major arc is bigger than 180, and I always define it with 3 letters. So this red arc here, A to D to B, I need 3 letters to describe that arc. And of course, a semicircle is halfway around the circle, and I use 3 letters to describe that as well. Okay? So WC is a radius. Identify XZY, arc XZY, X to Z to Y, as minor, major, or a semicircle. Well, the endpoints of X, Z, and Y, if I connect them, are a diameter. So that is a semicircle when I look at that. Okay? W to Z to X, same question. In that order, so W, I'm going to follow W to Z to X is that way. That is a major arc. That takes me more than halfway around a circle. Okay? Okay, let me go back here for a second. Then find its measure. Okay, semicircle is 180. If this is 90 right here and it's 360 all the way around, if I take 360 minus that 90, that's where they get that 270 for this angle here. Okay, and then XW, this one right here, certainly a minor arc, and the central angle is 90, so that has an angle that's 90 as well. Okay, all right, so your turn to give it a shot. All right, LO, L to O. Clearly a minor arc, you guys. And if this is 90 and this is a line, this is 90 here as well. So LO is 90. MLO, from M to L to O is halfway around the circle, which is called a semicircle, and that's 180 degrees. Okay, L to N to O, L to N to O is this way, okay? That's gonna be a major arc because it's more than halfway around. And we said that L to O was 90, so if I take 360 minus 90, I'm gonna get 270 for that one, okay? All right, in the same circle or congruent circles, two minor arcs are congruent if and only if their central angles are congruent. Okay, so 1 and 2 would be congruent if FG and HJ would be congruent arcs if angle 1 and angle 2 are congruent, okay? So I've got, I'm gonna need a calculator for this one. Refer to the circle graph, find the measure of arc KL, okay? It says KL here takes up 21% of the entire graph. And the entire graph is 360 degrees. If I take 360 times 0.21, I get 75.6 degrees. Okay? That's the measure of the arc in degrees. Okay? How about this one? N to J to L. N to J to L. Okay? That is everything but this little part here. Well, 9 and 7, that's 16. So if I take 360 minus 16, or I'm sorry, 100% minus 16%, I'm left with 84% of the circle. So if I take 360 times 0.84, that's 302.4 degrees, and this is kind of the math that they're gonna do here. 302.4 degrees, okay? All right, so you give it a shot. BC, 39% of the circle, so I take 360 times 0.39, I get 140.4. Okay? And ACB, A to C to B, is everything but this 24%. So 100% minus 24% is 76%. So if I take 0.76 times that 360 all the way around, I get 273.6, which is A. Okay? So the math here is pretty straightforward, you guys. Okay, arc addition. If I want to find the measures of arcs that are adjacent, I can just add them up, kind of like angle addition and segment addition. Okay, so LHI, okay, from L to H to I, well, if that's 90, this was 90 in here as well. So that's just going to be 90 degrees, you guys. They're doing more work, I think, than is necessary. But that's pretty straightforward. How about I to J to K? Okay, well, H to K, all the way around here is a semicircle, 180 degrees, and that's 32. This is the rest of it. So if I take 180 minus 32, I'm going to get I to J to K. Okay, so 180 minus 32 gives me 148. They went about it a little differently, but I think either way will give you a good solution here. So EAB, E to A to B, again, it's just that 90-degree little sector in there, no big deal. B to C to D is 180 minus that 38, so 142. And arc length, okay, if I want to measure it linearly in inches or feet or whatever I'm going to be given, I'm going to take the circumference, that's where you see the 2 pi r here, you guys, and then I have to multiply it by the fraction of the circle that's taken up. Well, that's going to be the measure of the central angle over 360. So if I take x over 360 and then multiply it by the circumference, I've got the arc length. Okay, so here, DA, that arc, the central angle is 40, so 40 over 360 times 2 times pi, and the radius is 4.5. So there's your central angle, there's your radius. The rest is calculator work. I put it into my calculator, press enter, about 3.14 centimeters there. Okay? DA, well, I first need to find the central angle, and if this is a semicircle from C to D to A, 180 minus this, or 152, is that central angle. That's going to be my x, right? So 152 over 360, that's what I get here, times 2 times pi times 6 is the radius. Now I can just type it in and get about 15.92. okay? DA on this one, central angle is 140, so same problem as the last one. Instead of 152, I'm using 140 this time. 14.67. All right. All right, your turn. Give it a shot. I'm looking for JL. 36 over 360 times 2 times pi times r. Okay, so I'm going to just type this in here now. 36 over 360 times 2 times pi times our radius, which is 6. I get 3.77, which is B. Right? JL, first thing I need to figure out, 180 takes me halfway around. 180 minus that 22 is 158. So I've got 158 over 360 times 2 times pi times r, which is 14 in this case. Let's see what I get. 158 over 360 times 2 times pi times 14. We get like 38.661. Yep, there we go. Arc length for this one, this is the same thing except 135, you guys. So 135 over 360. Times 2 times pi times 14. It's going to be close, not quite the same, a little smaller. And there's your assignment, you guys. 7, 10, 13 to 49 the odds. Make sure you get those formulas written down and do your best. Thank you.